Hello everyone and welcome to this video. In this video we're going to be taking a look at how to attack login forms with OTP security, or login forms that utilize OTP security for authorization. And in the previous video the objective was simply to give you that overview or that knowledge on how to attack a standard login form. But as you know, most modern login forms have two-factor authentication, and one of these forms of two-factor authentication is OTP. So we're going to be taking a look at an example, a practical example in this video as to how you can attack login forms with OTP security and essentially brute force the OTP code with a few considerations. So to begin with, before we begin the actual practical demonstration, we need to have an understanding as to what OTP security is and what it is used for, and what the pitfalls are, or what misconfigurations are typically made. So to begin with, what is OTP? OTP stands for one-time password, and OTP security is considered a two-factor authentication method that is used to enhance the security of user accounts and systems. Now, the one thing that most of you already know is that by good design, OTPs are designed to be temporary, single-use codes that are typically generated and sent to the user's registered device, such as a mobile device or even via email, to verify their identity during login or transaction process. Now, the two primary characteristics of good OTP security are, number one, the OTP code should be time sensitive, in that it should expire in a very short amount of time. Otherwise, if it is left valid for, let's say, a couple of hours, that opens it up to brute force attacks. Secondly, and most importantly, the OTP endpoint that is essentially verifying the OTP code within that time frame, the allowed time frame, should have rate limiting to prevent brute force attacks. Now, what happens when OTP security is not implemented in this way, or is misconfigured? Well, what happens in this particular case is attackers are able to firstly, again, brute force the OTP endpoint. And if the OTP generation process is not unique for every OTP code and has a sequence behind it, it can be very easy to brute force an OTP code. And more importantly, if the verification or the validity period of the OTP code is more than 30 seconds, it opens it up to potential attack. And that's what we'll be looking to explore in this particular video. Now, before we actually get started, we need to have an understanding as to the various OTP security methods that exist. So firstly, as you know, we have time-based OTPs, or TOTPs. So TOTPs is a widely used OTP method that generates codes based on a shared secret key and the current time. And these codes are typically valid for a short duration. So think of 30 seconds. And then you have your standard SMS-based OTPs. So OTPs can be sent to users via SMS messages. When users log in, they receive an OTP on their mobile phone, which they then must enter to verify their identity. So when we'll be taking a look at the lab, the objective is not where the user is receiving the OTP. The implementation in this case is an SMS-based OTP, but obviously there's no device. We're going to be taking the perspective of an attacker trying to brute force an OTP. And then, of course, we have rate limiting and lockouts. So from the perspective of the developer, they typically implement rate limiting and account lockout mechanisms to prevent brute force attacks on OTPs. And if we find that an OTP endpoint is not or does not have rate limiting, then we can do a lot of damage, as you'll see. So the primary objective in this video is to, again, test the OTP endpoint for rate limiting, and secondly, test it for validity, or essentially try and identify how long an OTP code is valid for after it has been generated. So we're not really concerned about where it's being sent, because again, from the perspective of an attacker, we are assuming that, we've tried to log into a user account and we've discovered that they have two-factor authentication, and we now need to brute force the OTP code to log in. So what is OTP rate limiting? Because it's very important to understand. OTP rate limiting is a security mechanism that's used to prevent brute force attacks or the abuse of one-time password OTP systems, such as those used in two-factor authentication. And rate limiting restricts the number of OTP verification attempts that can be made within a specified time period, making it harder to brute force. And that goes in conjunction with the actual expiry of the OTP code. So the bottom line is that rate limiting essentially ensures that you'll not be able to brute force the OTP code fast enough in order for you to essentially beat the actual OTP lifespan, if you will. So if the OTP code lasts for, let's say, 15 minutes, then the rate limiting should also complement that, in that it should prevent you from obtaining a valid OTP through a brute force attack in 15 minutes. So by enforcing rate limits, organizations can reduce the risk of attackers guessing or trying out multiple OTPs in quick succession. So our objective with this lab is to show you what this vulnerability, or to show you what OTP testing looks like. You know, in this particular case, we'll be focusing just on OTPs. The login form in this case is designed to pretty much operate or behave to essentially simulate the fact that the attacker is logged in, but the login form is now prompting the attacker for an OTP code that, again, the attacker is not aware of where it has been sent. So we now have to try and brute force it. So this video has a lab environment associated with it, and the lab environment will provide you with a Kali Linux system, so you do not need to utilize your own. And you pretty much fire it up and we're good to go. So I'm going to fire up the lab environment and I'll see you within the lab environment. All right, so I am back within the lab environment, and when you start up the lab environment, you'll be provided with a URL that'll take you to the web application that we will be testing. So as you can see here, it's very simple. I've just opened it up in Firefox, and it says, "Welcome to Attack Defense Labs. Please enter a phone number or your phone number here." So in this case, just based on how this was designed, we can just enter a random phone number like, 1, 2, 3, 4, 5, 6, 7, 8. And then we click on send verification code, and it's going to say, please enter the 4-digit OTP received on your mobile. And, we can say 1, 2, 3, 4, for example, just to test things out. We click on verify OTP right over here, and it's going to say incorrect OTP. So we're supposed to find the correct OTP. And in this particular case, we'll start off by intercepting the request with burp. So I'm going to navigate to Foxy Proxy here and click on the pre-configured burp suite and zap or zap profile. And this will automatically proxy our traffic from Firefox into burp suite. So I'll navigate into the menu here and into web application analysis and into burp suite. Because we need to understand what exactly is happening when we enter a phone number. So I'm going to create a temporary project and start that up. And we'll give this a couple of seconds to load up. Once it's up, which it is, I'm now going to go into the user options and into display. And I'm just going to change the font size to something a little bit more readable, like 24. And now if we're going to proxy, I'm just going to make sure intercept is set to on. And we'll submit this phone number again, and then we can see the first request that is made. So let's pay attention to what's going on here. So you can see that it's a GET request that's being sent to dev and send. So that's the endpoint, or rather the URL. And you can see the host is this host here. So that's API, AP, etc. In your case, it might be different depending on your region. And in this case, it's not using, it's added something here, which is send. So that's the endpoint specification there. And we can see the referrer is, of course, coming from dev. And then we have a cookie here. So we can see cookie session ID equals the following. So we have a cookie, and again, we're not really sure what it is used for. So we will just forward this request. And now you can see there's a GET request made to the API right over here, and this is actually Mozilla, so my bad for that. This is just the Mozilla GET requests here, so I'll just forward that there. And now it's going to prompt us to enter the code. So I'll just enter 4444 as an example, verify the OTP. And now there's a post request made to dev verify. So the endpoint for verification is verify right over here. And you can see that we have the cookie, and that sets the session ID, which matches what is included in the body of the post here. So you can see session ID, and then the OTP code is specified here. So from this point on, we can send this to the repeater for a little bit of testing. But the bottom line is once we hit forward, if we go back into the browser, it should give us an indication as to whether this is correct or not. And in this case, we're not got a response yet, which is very interesting indeed. So let's see if it loads up anything. So yep, nothing yet. We'll go into the repeater and we'll try and play around with this value here. So I'm going to send that 4444 and you can see the response says failed. So pay attention to the response messages. If I change it to something like 9898, just something totally random, hit send. Let's see whether we get a response here. I'm just going to give it a couple of seconds. Right over here, I think this may be because we did not halt that particular request. So I'm just going to cancel this and I'm going to close this repeater session. If we go into the proxy now and make sure intercept is set to on, I'm just going to verify the OTP again. And we're going to send this to the repeater one more time. I just want to test something. So we'll say 1212 and send that. Okay, so that works. If we now say 1213, let's see what that looks like. Looks like, yeah, for every new request, there is there's a new session ID, it looks like. It appears to be the case. We can obviously test this by, just saying forward. And now if we go back in here, you can see incorrect OTP, and we go into repeater. Again, based on what we're seeing here, it doesn't look like there are any, there is an expiry of the OTP, but of course I could be wrong. Let's test it with the, few more here. So I'll send this again, and let's see, okay, nothing there. We go to proxy, and what I'm going to do now is, okay, this is just Mozilla. If we go back in here, let's take a step back, send the verification code. We'll send that one. And then now we enter the code here. So I'm just going to enter 1111, verify the OTP again. And now I'm going to leave that in the, I'm not going to forward that particular post there. If we just send this one, okay, we don't get a response. We change this to something like 2. Do we get a response here? It's still sending, but we send this here. Okay, so that failed. If we say send this one here, so 1113, nothing there. So yeah, okay, I'm starting to understand how this is working. So what we can do now is, because we need to test, and we need to test this endpoint to see whether there is verification. We need to test this particular endpoint to see whether there's any rate limiting. We need to utilize OWASP ZAP, and the reason for that is fairly simple. OWASP ZAP does not have any rate limiting features with regards to the intruder, or rather its fuzzer as they call it. Whereas Burp Suite Community Edition has those limits, so we'll not be able to tell whether we are successful or not because it's too slow anyway. So I'm just gonna close up Burp Suite here, and I'm still proxying traffic through the actual profile in Firefox in Foxy Proxy. So I'll go into Web Application Analysis. I'll actually take a step back here. We'll go to Web Application Analysis and we'll go into ZAP. And from this point on, we're just going to wait for ZAP to load up. All right, so ZAP is loaded up. I'm just going to copy the endpoint here. And now if I go into ZAP, I'm just going to expand that and we'll click on Manual Explore. I'll just post that in there and I'll launch the ZAP browser here just so that it's all internalized anyway. And now within the ZAP browser, we're just going to follow through. So 1, 2, 3, 4, 5, 6, 7, 8, 9 as an example. And then the verification code will say 6767, something very basic like that. And you can see incorrect. Now in Zap right over here, you can see that we have the actual endpoint there. And under dev, you can see we have the post here. So we can now fuzz this. So we'll right click, attack, and we'll go into fuzz. And just like Burp Suite's intruder, we just specify the position that we would like to add, or the fuzz location in the context of Zap now. And what we'll do is I'll just expand this a little bit. And remember, we want to fuzz the API here. So I'm going to add that as a position. It's now going to ask me for the payload. So in this case, because it's numbered, we want to use the numbers type. And we want to start from, let's say, 1,000 all the way to 9,999. So this is the range of pins or OTP codes that we want to essentially fuzz for, or perform a brute force attack on. So we're hoping that the correct OTP code is somewhere between 1,000 and 9,999, and will increment by 1. And you might be saying, well, that's going to take a long time. Well, firstly, we're testing against an API, and this will tell us whether we have any rate limiting. And secondly, OWASP Zap's fuzzer is incredibly fast. So we'll only increment by 1, and I'll add that here. So I'll hit OK. So that position has been added now. And what I'll do now is I'll also go into the message processors, and we'll add a tag creator here that will essentially allow us to filter or categorize results from the fuzzing as to, essentially sort them to be able to tell whether a request failed or was successful. So in this case, we will filter for failed requests. So we'll use a regex, and we'll just say failed based on the response we analyzed in Burp. We know that that is the case here. So we will just use that there. And from this point on, the tag name will just be called failed, like so. And I'll hit add and hit start fuzzer. And almost immediately you can see how many attempts are being made here. So firstly, you have the task ID, the message type, the code, the response code, the reason, the RTT, and then the state here based on the tag that we had created. So in essence, we're looking for a change in the size of the response header. And right over here at the top, you can see the completion and the number of messages sent. So based on what I'm seeing here and the status code here, the response code, it doesn't look like this particular OTP endpoint has rate limiting. So now it's just a matter of playing around with the range to see whether we can identify a valid OTP code. So I can go into this column here under state and try and filter for tasks or fuzzing attempts that do not have the failed state set. And again, remember we set the tag here to essentially show the failed attempts, and anything that does not have that tag means that it's probably successful. So we're just going to look out for this. I'm not sure when we'll get a positive result, so I'm going to let it run to the maximum range, which is 9,999. And we're just going to try and filter this as much as we can here using the columns, and we can also do that using the size of the response header. So just, trying to filter that way. The original one is the only one here that is not failed, because we can see the request here was, 6767, and the response was probably that it failed as well. So we'll click on that here, and you can see status is failed. So I'm just going to let this run, and I'll let you know when I have a positive result. All right, so I didn't have to let it run for too long. Pretty much the 1999th fuzzing request here pretty much gave us a success. And pay attention to the actual response here. In the response, you can see that a new header is set called set cookie right over here, and it has the session ID. And in terms of what the code was, we can see right over here that the OTP code was 2998, which is absolutely fantastic. So I'm going to stop the current fuzzing attempt here. And what we can do now is pretty much just try and make a request even with Burp Suite, and then copy this particular session ID that was sent in the response. So this one right over here. And we pretty much just need to copy it and we'll then replace it when we make a new request. Now, the one thing that I would like to point out is please do not use my code that I've obtained in the video, because in your case, your code will be different. So please keep that in mind. And also, if we right click here, we can open this up in the browser here. So we'll say Firefox. And in here, if we then halt this, so not under verify, but more so under the original request. So for example, we'll go to dev here, and I'll just I'll just add a I'll just set a break there. My apologies. We have quite a few Firefox windows, but I'll just set a break there. And in this particular case, if I now say verify, or if I go back to dev, you can see, we'll just hit OK. And here we can just set the session ID that, so this is the breakpoint. So yeah, we'll just replace it with the one I copied from the successful OTP brute force. So right over here, just paste that in there. And if I now just play that again, we'll go to one of our sessions here. Not sure which browser session it is. It's most likely session 2. There we are. We are successfully able to authenticate and log in, and we get the flag. So just to recap what has happened here, we found the correct OTP code. Why was that the case? It was the case because these OTP codes did not look like they had any expiry, at least in the short term. And secondly, as you can see here, we performed, it looks like 3,886 brute force attempts, and there was no rate limiting whatsoever. And just based on the fact that those two security mechanisms did not exist, we were successfully able to get an OTP. Now, the key thing to note is that in this case, the OTP code was just 4 characters, which made it even easier, and the actual range was quite small, 1,000 to 9,999 was not that large, especially when you're utilizing a tool like Zap. But we were successfully able to get the code. And in your case, the code will be different because that's how the web application works. It's supposed to work like a real OTP, like a real OTP endpoint. So hopefully you'll actually have a lot of fun with this one. But that brings me to the end of the practical demonstration side of this video. All right, so that was how to attack web application login forms with OTP security enabled, but with a few misconfigurations. So as I said, hopefully you found that useful and informational. Now that we've covered the primary broken authentication attacks or vulnerabilities that I wanted to cover, we're now going to turn our attention to one of the major sections within this course, and that is going to be around session management and session security in general. So with that being said, that's going to be it for this video, and I'll be seeing you in the next video.